Good afternoon, everybody, and once again, welcome back to my channel. In today's video, I want to show you a complete hands-on deep guide on how you can leverage Hudi streamer slash Delta streamer to build a slowly changing dimension. Also, the Hudi streamer slash Delta streamer is operating in a continuous mode, meaning it is constantly listening for new data from your bronze or silver zone and it's updating your dimension tables in real time. This guide shows how to leverage SQL based transformer, how to write SQL queries to implement a slowly changing dimension. Not only that, this video also shows you how to perform Hive sync with your external Hive metastore. In this example, we'll use Postgres as our Hive metastore. The data is synced constantly with your Hive metastore. And not only that, we'll show you also how you can run real-time queries on this data using Trino. So let me show you what we are about to build in the video, and I hope you are excited for the video. So we'll take an example for customer, but this could be easily extended for other table as well, right? You will have a customer Hudi table, right? Here I'm showing you we will have a customer ID, name, city, state, created at, and a timestamp column. Now using Hudi streamer, we are only gonna pull incremental changes. Let's say tomorrow, customer one was updated, or let's say it was some, changes in the email address, right? So these changes are captured by the Hudi streamer, right? And the Hudi streamer will use the SQL based transformer, will provide a file called transform.sql. There, this particular Spark will basically, get the incoming records, and then based on that it's going to perform a slowly changing dimension on our dimes underscore customer. The beautiful part about this is the output table could be interoperated as Hudi, iSpark, or Delta, which means the Hudi streamer itself is building the metadata for all the three lakehouse format. Now during the process, the streamer is syncing the data with the Hive metastore, which allows the end user, data scientist, analyst to run real-time queries against this dimension table using Trino. So all of that is there on the video. For the object store, we are leveraging Min.io. So I hope you are excited, and there is a lot to learn. So this will be a little lengthy video, about probably 30 or 40 minutes, but I will ensure that every single steps and basics are covered. So if you're excited to learn, let's get started with the labs. So it's time for the labs. So first part is we navigate through the project directory, and then we can understand each particular file, code, etc. All right, so in this project, you will have a folder called jar. This folder will have all the necessary jar files. I do want to open this. I'll take out time to show you everything here. So you will have three jar files: Hudi -java client jar, Hudi utility slim bundle jar, and Hudi extension snapshot jar. We need these three jar files. The next folder that we have is Trino. Inside Trino we have etc, and then inside that we have a folder called catalog. Inside catalog you will see hive.properties and hudi.properties. Inside hive.properties we use the connector name as hive. We provide the metastore URI, the AWS access secret. This is our object store, which is Min.io, right? Similarly for hudi.properties, we provide in that the connector name is set to as Hudi. After that, if you open up node.properties, here we simply declare the node environment is Docker, the node data directory, and the plugin directory over here. Then we have a file called hudi_tbl.props. This is where all your Hudi related configuration should go over here. After that, you would have a file called join.sql. This file is responsible for doing the slowly changing dimension using Delta streamer, which we will explain in detail. After that, you have a Python file called read.py. This is used to read the data using PySpark from our Min.io buckets. After that, you have Spark conf.properties. All the configuration related to Spark is basically stored in the spark-config.properties. Then you have a Jupyter notebook, which is called Trino.ipython notebook, which shows you how to query this data real time using Trino. So hopefully so far everything looks good. Now you also have one more file which is called dockercompose.yml file. The Docker Compose file is used to spin up Trino, Hive, Metastore, MinIO, as you can see. Here we are simply spinning up Trino coordinator and I'm using the version 400. Port for the Trino is used as 8080. I'm using Postgres version 11, which is used as a Hive Metastore, and the host name is set to metastore_db. This is my Hive HMS, as you can see, and here I provide the configuration. So if I scroll here you can see JDBC PostgreSQL : the container name followed by the port followed by the database name. So I will collapse over here. Then I have a MinIO container, as you can see, the MinIO user, the password, and the domain, as you can see over here. So hopefully you are familiarized now with the project directory. When you do clone it from the GitHub, the jar files won't be there, so you need to download the jar file. Make sure you download them from the Maven repository, or I'll try to leave the links to my Google Drive where you can click and download all the jar files. All right, so now hopefully you are familiarized with the structure. Now we can spin up the entire components using Docker, right? So now please allow me some time while I pull up my terminal and everything. So what I will do, pwd, I'm gonna copy this directory and I'm gonna open in my Mac terminal, cd, and I will zoom in as much as possible over here. Now what we need to do is we need to start all these containers, and for that we will say docker compose up --build -d. This will start the container running in the background. Here you can see it has started about 1, 2, 3, 4, 5 containers, right? And this usually takes time, so go to your Docker desktop and verify if these containers have started. Let me see if I can open up my Docker desktop. I think I have my Docker somewhere, just not sure which screen it is. Probably somewhere here, I'm not sure where exactly it is. Oh, here I can actually open up from the drop down. All right, so here you can see all these containers are now running, which means you are okay to go ahead and you can perform this lab with me. So make sure that these containers are in the running state. All right, so now we will do the slowly changing dimension and the streamer part. This is the part where you need to understand a little bit, right? So first, let me show you the slowly changing dimension part. We made a table called customers, right? Everybody so far with me, right? Now, I want to create a table called, dimes_customer, which will have a customer ID. And the way I will implement the slowly changing dimension is I need a flag, or I would want to have a flag called isCurrent. That means, see, let's say customer 1, 2, and 3. When it comes, these flags are gonna be true. Next time, let's say customer 1 changes email address from, let's say, abcd.com to foo.com. What would happen is when that record comes into the dimension table, the old record would be there, but we would mark the flag isCurrent to false, and we'll insert the new record with the flag isCurrent true. So now you can see the changes and you can see, oh, okay, so this guy changes email address from here to here. So that's the goal, okay? Hopefully made sense, right? All right, so that being in mind, I need to create this table, and then I'll go over the main part, the core part, the Hudi streamer. So I'm gonna register this particular table called dimes_customer. So let me just show you the SQL. Again, hopefully made sense, right? Create table customer_dime. This is the primary key, which is gonna be random UID, right? It's a dimension key. Customer ID, customer name, state, again, a bunch of columns. The important one is isCurrent, right? That's the one that's important. So I'm simply creating this table at this point using Spark, okay? And then I'll show you the streamer part. That's the main part that we need to focus, okay? All right, now we have these two tables, right? Now I need the Hudi streamer part, meaning I wanna go from the customer table, I wanna grab all the data that's coming in, the new changes that are coming in, and then what I wanna do is I wanna dump it into the dimension table. So now I need to explain a little bit theory here, how to achieve this, right? Now, why it's a little complicated or complex here. So to implement this, right, let's consider a very simple use case. Customer 1, 2, and 3, right? It's there in the dimension table, assume. In dimension, you have customer 1, 2, and 3. Next time when customer 1 has changed, let's say the email address, let's say I don't know, dot to foo.com. Now what you need to do is first the new incoming records that are coming in, the delta streamer is always gonna pick up new delta or new batches of record from the table. Now you first need to see if that incoming record is there in the dimension or not, right? If it is there in the dimension, right? If it's there in the dimension, the old record where is current is true, you need to set that to false. And for the new records which is coming in, for that you need to set the is current to true. And then you need to combine these two data frames, right? You have to union that and then you have to upsert into the dimension table. So that way in the dimension you will have the old and the new. Make sense? If not, once again. All right, I try my best, okay? Let's say in the customer dimension table, you have 1, 2, and 3, okay? Now, when you're reading data from the customer table, bronze, silver, whatever that is, right? When the new records are coming in, now first you need to see if these records are there in the dimension or not, right? If it is there in the dimension table, you need to mark is current, the old record in the dimension as false, and the new record is current will set to true. Once that is done, take the new record, take the old record that you have modified, union it, and then pass it to the delta streamer, which is gonna perform upsert, right? All right. So hopefully made sense. Now let's look at the implementation. And also the delta streamer is gonna build the metadata for iceberg and delta too, right? All right. So I hope I tried my level best to explain as much as I can. Now here let's see. Spark submit class or.apache.hudi.streamer.hudi streamer package. We use the Spark bundle package and AWS package. We provide all the configuration through Spark config property, right? So coming here, right? Simple, right? Access secret, and then here important. I'm setting spark.hadoop.hive metastore to this, right? So hopefully and then I'm setting Spark SQL catalog implementation to Hive. Where is my nodes? Okay, here. Simple memory, jar files, table type, copy on write, target where I want to build my table, name of the table, method is absurd, enable sync. This is for Apache X table or one table, however you like to call, enable Hive sync. We're using the sync class as io.onetable.hudi.sync table, one table sync tool. This is important now. Transformer class. I'm gonna go over this SQL shortly for the slowly changing dimension, right? We're gonna use a file-based SQL-based transformer, right? And then we are providing all the configuration through Hudi table.props. Now let's take a look at the Hudi table.props, and then hopefully, I guess I'll try my best to show you the big picture here. Okay. Hudi streamer.source.hudi incremental.missing .checkpoint.strategy is set to read up to the latest commit, right? And then this is the path to the bronze customer table, because the Hudi streamer has to read only incremental data. We do not want to do a full table scan. That's expensive, right? So hopefully made sense, right? The record key, so come here. So for this one, for the dimension, the record key is going to be customer dime key. Okay, I'm not partitioning the data right now, again just keeping it simple. Dedupe will be timestamped, and then here Hudi streamer transformer.sql.file. So my slowly changing dimension Spark SQL I'm providing to this through the SQL file, okay, which I'll show you. So now let's see that. Now hopefully with all the explanation I've done so far, a long video, hopefully made sense. Let me collapse this and then I'll try. Okay, so with updated records, so we are getting, right, all the new data changes, delta, right, from the bronze table. So here you can see this is a syntax that you gotta use. And then what I'm doing is, look, select everything from the dimension, inner join on the incoming records dot customer ID dot u dot customer ID. So what it's doing is, like, let's say, again, I'm trying my best to explain you this, right? If customer one is coming in, right, I first need to see if that customer one is there in the dimension. If it is there, I have to change the is current to what? False, right? For the old record. And the new record, I need to set it to true. And then I need to union that, right? So So hopefully now it's a little clear. So what I do is in order to check, how are you going to check? By joining, right? By incoming records that are coming in, I'm joining that with a dimension and saying, okay, hey, is it there or not? If it is there, now watch. If it is there, right? Where is that? Where is that? I think it's down. If it is there, I set that to false over here, right? So I'm gonna go over this, okay? So here I select all the incoming records that are coming in by Delta Streamer, okay? All the delta, right? Over here I select I select the records from the dimension table that matches the incoming record. That's the easiest way I can explain now. So again, I'm selecting the records. That matches the incoming records on customer ID, right? So I did that. Okay. And then what I'm doing for the new records, right? Remember now for the new records, right? If customer one is not there in that's basically a new record, right? Then I need to insert it. So I need to generate customer dimension key. I need to generate that. So I'm using UUID, right? And then all the other items again, as you can see over here. And then I repeat, I set is current to true. Union, now I'm selecting the old record if there was a match, right? If customer one was there in the dimension, right? If it was a match, right? I need to select the old record and I need to mark the is current to false. So look at this, from existing records, false as is current, right? So if the record was there, I'm setting is current to false. Again, it's a little lengthy SQL. If you are completely new, I understand it's going to be a little hard. So, pause the video or at least try to go over the SQL code if possible, right? So I hope that made sense. I tried my best there. Now, going back to my notes, okay, now what I'm going to do is I'm going to run the streamer, right? So again, this streamer is running in a continuous mode, right? Where is that flag? Continuous, right? And it's going to do, oops. Okay, yeah, it's gonna do a sync after like 20 seconds, right? Whatever you decide. So what do you want to do, right? So now let me first open up a couple of terminal. Here I have my Spark, so I'm gonna open it over here. So first I need to set my Java home here. All right, so ready everybody? We're gonna fire that, okay? And before that, I think I want to run my Trino, so I need to start my Jupyter Notebook too. So I'm gonna open up one more terminal. PWD, let's go. Okay, so here I need to activate my virtual environment and I'm going to start my Jupyter Notebook because I want to show you the query through Trino too, right? So where is the command? Where is my command? I had it somewhere. I just don't know. It's something like conda. You know what? I think I have it on one of my blogs. So I'm just going to copy that from my blog. So I open up Safari. I'll navigate to my blog, and I know there was one blog that I did where I used it. So here, conda activate my virtual environment. So I'm going to activate that. And then I start my Jupyter Notebook over here. Yep, perfect. And then here, as you can see, I'm also going to go to localhost 8080, where you will see your Trino. And I use admin, and here you can see my Trino, right? So I have my entire setup ready. Let me open my Trino.ipython notebook. All right, so now I explained you the entire command. Now we're gonna submit the job, right? We're gonna start the job. So are you ready and excited? I hope you are. I hope you are. I mean, this is really, really cool, So I copy this. Let's see. I think I want to do it here. All right, so right now there's, as you can see, I'm gonna submit the job. Okay, 3, 2, 1, boom. Okay, so the Delta Streamer now is running. It's running in a continuous mode. It was able to read the SQL. Okay, now look at the beautiful part that I'm going to show you. So let it do its job. Now, if I go here, and you can see customer dime. Here you can see the metadata for Iceberg and Delta. I can interoperate, right? I mean, it hopefully made sense, right? All right, so this guy is running. Now I can open up my Trino, and you can install these two libraries if you don't have it. So So now I'm reading the data from the customer dime, right? Now observe something very carefully I want to show you. Okay, observe customer 1, customer 2 and customer 3, right? Now comes the fun part. We're gonna go and update the email address for one of the customer and you will see the slowly changing dimension in action. All right, are you excited? Again, streamer is running in the background, right? So now the fun part, as I say, let me see where is my update command. Okay, so I'm gonna update the customer, where the customer ID is 1, I'm gonna update the email to like star whatever. So I have my Spark SQL here, right? I'm gonna fire this command and this should update the data where in the silver or the bronze, however you like to call. So that's done. Now the streamer, as you can see, it's syncing the data now. After every 20 to 30 seconds, whatever you have set up, it's gonna sync it, right? So yeah, now you can see, right, if I'm querying my customer table, right, let me bring that diagram here. So the customer table, right, we updated the email for customer 1, right, and as you can see, customer 1, we have that star, right. Now if I run the same query on the dimension table, look what happened. So customer 1, that update came in, right, and the flag is set to true, and the customer 1, the older email, now is now set to false. So which means now I can see the changes here, right? I can see, yeah, you know what, customer 1, the previous email was John at example, now he updated to this email. I can track these changes, right? Yeah, that's all I have for the video. This is a complete solution on how you can implement slowly changing dimension with Delta Streamer, Delta Streamer operating in a continuous mode, right, and querying it real time through Trino. So again, I do wanna I just wanna cover the SQL. That's the important part, right? So just recapturing everything. So first, when the incoming records come in, we need to see if that incoming record is there in the dimension or not. If it is there, and how you basically identify is by joining that. Join the incoming records with the records from the dimension table. Once you do the join, now you know if that record is there in the dimension or not. Once you know if the record is there in the dimension or not, the older record you need to set that flag to false, and the newer record you need to generate a new dimension key, and then union all, and then you pass it to the Delta Streamer, which is again gonna do the observe. I know there's a lot in this video. Looks easy, right? The video itself is long. Although it looks easy, there's a lot of steps, lot of configuration, lot of settings, lot of Spark SQL here and there, couple of optimization, right? If again, since you're reading these changes incrementally delta, right, you could now again for optimization, again what you can also do, if your dimension is small, you can perform a broadcast join there. Broadcast join will broadcast the smaller tables to all the worker nodes, so the join can be done much more efficiently without the shuffle. So it's going to be even more faster. Number one, you're only pulling deltas or incremental data. That's point number one. Number two, it's going to be fast because you're only doing incremental changes, right? And then you can even optimize using a broadcast, right? Not only that, you can also interoperate with all these lakehouse format. I know there's a lot, so I hope you have enjoyed this video, found a lot of value in this. I'll leave all the code resources in the GitHub section, so make sure to check it out. Blogs are coming on soon on my LinkedIn where I'll explain every single step in detail. That's all I have. All I ask you in return, if you have watched the video till the end, simply comment that, hey, I watched to the end, I liked it. That will really motivate me a lot. That being said, thank you so much for watching the video. Keep smiling, keep programming, and I'll see you in the next video.